Hello, this is section 9.6, Graph Quadratic Functions. Part 1, Graphs of Quadratic Functions. A quadratic function where a, b, and c are real numbers and a is not equal to 0 is a function of the form f of x equals ax squared plus bx plus c. Example 1, graph the quadratic functions f of x equals x squared and g of x equals x squared minus 1 just by plotting points. So we have x, and then f of x. Whenever you're told to graph something new just by plotting points, you should always pick two negative numbers, 0, and two positive numbers. So I normally pick these 5 values, but you can pick any values you want. Well, now f of x is equal to x squared, so I square all those values. Negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. And now let's go ahead and plot these. I'm hoping you can see that if we assume this pattern continues, that it makes this U-type shape. Well, now let's do g of x. Again, I'm going to choose the values negative 2, negative 1, 0, 1, 2. Now I need to square them and subtract 1. So we'll get 3, 0, negative 1, 0, and 3. And now let's plot those. Again, if we assume this general shape, we'll get this U shape. The graph of every quadratic function has the same shape. We call this U shape a parabola. Parabolas can open upward or downward. The sign of the leading coefficient a determines which direction it opens. If the leading coefficient is positive, the parabola opens up. If the leading coefficient is negative, the parabola opens down. Example 2. Determine whether each parabola opens up or down. So A is 2, which is positive, so it opens up. A is negative 3, which is negative, so this one opens down. Here, A is actually negative 5, so be careful. It's not always the first number. It's whichever the coefficient of x squared is. And because it's negative 5, this one opens down. Part 2, axis of symmetry in vertex. Recall the standard form of a quadratic function, f of x equals ax squared plus bx plus c, where a does not equal 0. Parabolas are symmetric over a line that we call the axis of symmetry. That is to say, if we folded the parabola in half along this line, the two halves would overlap perfectly. The equation of the axis of symmetry for the graph of f of x equals ax squared plus bx plus c is the vertical line x equals negative b over 2a. The vertex of the parabola is the lowest if the parabola opens up, or the highest if the parabola opens down, point of the parabola, and lies on the axis of symmetry. Because we know the x-coordinate of the vertex of negative b over 2a, to find the y-coordinate, we just plug negative b over 2a in. So in other words, the vertex has coordinates negative b over 2a for the x-coordinate, and then f of negative b over 2a for the y-coordinate. Example 3. Find the axis of symmetry and vertex of each quadratic function below. So part A, f of x equals 3x squared minus 6x plus 2. A is equal to 3, B is equal to -6, and C is equal to 2. So our axis of symmetry will be x equals -6 all over 2 times 3, which ends up being 6 over 6, which is 1. Then for the vertex, I need to do f of 1, which is 3 times 1 squared minus 6 times 1 plus 2, which is 3 minus 6 plus 2, which is -1. So then the vertex is the coordinate 1 from the axis of symmetry and -1 from the calculations we just did. Part B. Well, A is -2, B is -4, and C is -3. So then our axis of symmetry is x equals -4 over 2 times -2, which is 4 over -4, or -1. Then to find the vertex, I need to plug that into the function. So we get -2 times -1 squared minus 4 times -2 minus 3, which is -2 plus 8 minus 3, which is 3. So then our vertex has the coordinates -1 from the axis of symmetry and 3 from our calculations. Part 3. Intercepts of a parabola. Recall the x-intercept of a function is where the graph crosses the x-axis. To find the x-intercept, we set y equal to 0 and solve for x. And the y-intercept of a function is where the graph crosses the y-axis. To find the y-intercept, we set x equal to 0 and solve for y. Example 4. Find the intercepts of each parabola. I'm going to find the y-intercepts first because those are always the easiest, because you set x equal to 0. So of 0, which is 0 squared minus 2 times 0 minus 8, which is -8. So our y-intercept is 0, -8. Now for the x-intercept, we have to set y equal to 0. And remember, with a function, f of x represents y. So we get 0 equals x squared minus 2x minus 8, which means we get 0 equals x minus 4, x plus 2, which means x minus 4 equals 0, or x plus 2 equals 0. So we get x equals 4, or x equals -2. So our x-intercepts are -2, 0, and 4, 0. So notice a parabola can have two x-intercepts. That's different from a line. Part B. So again, I'm going to start with the y-intercept. Plug 0 in for x. You get 0 squared minus 4 times 0 minus 12, which is -12. So our y-intercept is 0, -12. Then I replace g of x with 0 to find the x-intercept. So we get 0 equals x squared minus 4x minus 12. This is factorable again. X minus 6, x plus 2. So we get x minus 6 equals 0, or x plus 2 equals 0, which implies x equals 6, or x equals -2. So we get -2 comma 0 for one x-intercept, and 6 comma 0 for the second x-intercept. Notice that the number of real solutions, which we can find via the discriminant, sorry, misspelled it there, discriminant, can tell us how many x-intercepts to expect. And finally, part 4, graphing quadratic functions. Using the information we can pull from a quadratic function like its vertex and axis of symmetry, as well as the intercepts, we can graph quadratic functions. So instead of just picking random points, we're going to use these specific points. So graph f of x equals x squared minus 8x plus 12 using its properties. First thing I'm going to do is find the axis of symmetry, which is negative b. So negative, negative 8 all over 2 times 1. So we get 8 over 2 or 4. So let me graph that as a dashed line. X equals 4. You know what? I don't want that to be there. So I'm going to say each tick mark is 2. So we get 8, 6, 4, 2, 0, negative 2, negative 4, negative 6, negative 8, negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8. So that's why the green line is at the second line. Okay, now our vertex, we have to plug that 4 in. So f of 4 is equal to 4 squared minus 8 times 4 plus 12, which is 16 minus 32 plus 12, which ends up being negative 4. So 4, negative 4. So there's my vertex. Now let's find the y-intercept. That's plugging 0 in for x. So we get 0 squared minus 8 times 0 plus 12, which is 12. So 12 is actually going to be off my graph, about up there. And last but not least, we have the x-intercept. So saying f of x to 0. So we get 0 equals x squared minus 8x plus 12. 0 equals x minus 6 times x minus 2. X minus 6 equals 0, or x minus 2 equals 0. X equals 6, or x equals 2. So our x-intercepts are 2, 0, and 6, 0. And there's our parabola. And that's the end of section 9.6.